Hi friends, welcome to Civil Architecture Tutorials. Today we discuss how to find the quantity of steel in an RCC slab. So let us suppose this is a slab, and always the slab has got this is a shorter span and this is a longer span, and the longer span comes to 6 meter and shorter span comes to 3 meter. Okay, and we know where we are placing the main bar. It is always at the bottom and it will always be in the shorter span, and we are placing the distribution bar in the top and it will be always in the longer span. So if we know that, then we should know the spacing in between. So suppose in the spacing between the distribution bar and the main bar are same. Okay, spacing means from this bar to this bar, this bar to this bar, here also this bar to this bar, this bar to this bar, like that. It should be 125 mm if it is given at 125 mm. If that 125 mm is converted to meter, means 0.125 meter. Okay, so now we want to know one more thing. I will say distribution bar I will write it as dB, and main bar I will write it as MB. Okay, so now we want to know the number of main bars in the shorter span. This is the shorter span, so how many main bars like this have to be given, we have to buy, because before concreting a slab, the site engineer need to know how many bars in short span and how many bars in distribution bar, so that he can order the quantity for that to the steel shop. So for that we need to, the site engineer had to do all these exercises before ordering that steel quantity. So let us come to the point, the number of main bars. There is a formula for that, that is the number of main bar. Here the main bar is this number of main bars is equal to longer span by spacing, that is longer span 6 meter by spacing between these two bars, this main bars, that is 0.125 meter plus 1, longer span by spacing of main bar plus 1, that is here it is 6 meter, which is the longer span by the spacing is 0.125 plus 1 gives 49 nanometers. That is, in this slab, for this particular span of the slab, we have to provide 49 numbers of main bar. Okay, similarly for distribution bar, these are the distribution bars like this, the longitudinal one. For that the formula is shorter span. Shorter span here is 3 meter, this 3 meter shorter span. Shorter span divided by the spacing of the distribution bar, which is also the same, like 0.125 plus 1 gives 25 number. So we got this number of distribution bar also, and also we got the number of main bar 49 and 25. And the dia, suppose that both these bars are the same dia as 12 mm. Okay, it could be different, but here I am giving us an example of 12 mm only for both distribution as well as main bar. So the total length of main bar is 49 numbers we got, 49 numbers only. So we need to know the total length of main bar. Okay, so we got the 49 numbers, but we don't know the total length of the steel in the for the main bar. For that, 49 into what you have to do, into 3, 49 comes is for the main bar, so it will be the shorter span. So 49 into 3, this is shorter span 3 meter, which comes to 147 meter. Similarly, if you convert the main distribution bars into the total length, that is in meter, the same thing we have to do, 25 numbers into 6, that's a distribution bar which is in the longer side. 25 into 6 gives 150 meter. So if we add these two, we will get the total number of steel required for this slab. Since it is of the same dia, we can order it as the same dia. So total length of main bar and distribution bar comes to 147 plus 150, which comes to 297. So that is the total length of 12 meter dia for this entire slab. Okay, and now how to get the weight of that total length of steel bar. Now we got only 297 meter, which is the length of the steel bar, but usually when we buy steel, we have to ask them we need this much weight and not about the length. So we have to know the weight of the steel for this much length of the steel. For that we know the density, we know the unit weight of steel is d square by 162 into length of that particular steel per meter. That is, if it is 12 mm, Then d square is the diameter of the bar, and by 160 is a constant into length of 1 meter of that 12 bar. That gives kilogram per meter weight of the steel. So we know the total length, which is 297. So that should be multiplied with d square by 162, which comes to 144 by 162 into 297, gives 264 kilogram of steel needed. So we need the total weight. We have to go to the steel shop and say we need 264 kilogram of steel to make this particular slab. So I hope you understand by this video how to calculate the shorter span and the longer span, or the main bar or the distribution bars of this particular slab, or a slab in general. So I will come with a new subject in another video. Till then, goodbye. Please subscribe, share and like. Thank you very much.